Ken Moore.
Good afternoon, everyone. My name is Scott Hamill. Welcome to the UAA Professional Development Seminar. This is our first October seminar. Our topic today is the Port of Nome modification. And so we are super thankful to have Brian Hudson from P&D here today to talk about Nome. So,
Thanks, Scott. There we go. Okay, so now that I got the hang of this. So welcome everybody. Thanks. As Scott said, I'm Brian Hudson from P&D Engineers, and I've been invited to give everybody a rundown of the upcoming Port of Nome expansion project. I'm proud to have acted as the project engineer for the city of Nome on the design of the new docks over the last 2 years. And I'm really excited to see this project coming together and go out to bid later this year. Thanks to UAA for putting on the seminar series and letting me share all the exciting stuff that's coming to Nome. So just in case some of us don't know anything about Nome or where Nome is, it's located on the southern coast of the Seward Peninsula on the Bering Sea. It's about 540 miles northwest of Anchorage, 160 miles east of the U.S.-Russian border, and there's supposed to be a video playing. It was founded in 1901 after the discovery of gold in 1899, and gold mining still plays a significant role in the industry up there. It's home to 3 culturally distinct groups of Inuit people, the Inupiaq, Yupik, and the Siberian Yupik. Research history dating back 6,000 to 10,000 years. There's no roads in or out of Nome that connect to the highway system. The only ways in and out are via boat, airplane, or famously is the finish line to the Iditarod race, travel like dog sled. See if I can get this to play. If not, we'll just keep going. It was supposed to zoom in on the location. Before I get started into the project, I'd like to give the team that pulled this together over the last few years a little recognition. So our team consisted of the City of Nome in conjunction with the U.S. Army Corps of Engineers, the Port of Nome, and the Nome Joint Utility Services. The City of Nome contracted P&D engineers to do the design of the structural design of the dock work that we'll go over in this presentation. P&D had Owl Ridge under us to do the permitting aspects of this project, which were pretty significant as well. Through the port and the Nome Joint Utility Services, CRW provided all of the utilities work. And over the past 2 years, this team has met multiple times a week and spent a lot of time working with each other to pull together a package for phase 1 of this project that will go out to bid here later this year. So from the beginning of this project, we set out with a few objectives. This is to serve as the United States' only deep water port in the Arctic, to provide and continue a critical link with the Bering Straits communities and the rest of Alaska that are served by the port. The existing port facilities, as you can see here, are overcrowded, and this was meant to serve the overcrowding in the existing facilities that continue to grow every year. In addition to growth, they're also seeing deeper and larger and deeper draft vessels, and recognizing that the facility needed a deeper draft port. And then some other things like improving support for search and rescue, natural resources that are in the area, or access to natural resources that are in the area, and also just improving the overall efficiency of the existing facilities. So little bit about how we got to where we were at. So in 2020, the Army Corps of Engineers issued the Port of Nome Modification Feasibility Study. This was an update and a rework to an earlier study from 2016 that did not consider the Water Resources Development Act, the WRDA, in its justification of why this port should be expanded and modified. So the Water Resources Development Act allows you to justify projects on different bases than just net economic development, like the 2016 report it looked at. It allowed things to be considered like community viability, public health and safety, subsistence resources, and cultural significance. And so the 2020 report was able to justify the project based on an updated net economic development, as well as the critical support that the Port of Nome provides to many surrounding communities in the Bering Straits region. After 2020, the design agreement for this was executed in June of 2021. We've been at work on designing the project with the Corps of Engineers and the Port of Nome since then. The 2020 report selected alternative 8B for construction. There was, I think, 10 to 12 alternatives that were considered in the original 2016 study. That was winnowed down to 7, but they kept the same names. 8B was the one that's selected. And I'll give you guys an overview of that here shortly. So as far as where we're at right now, we have all the permits in place. The design is at 100%, and we are still putting the finishing touches on all the bid packages and everything. That should hit the streets sometime in late November or late October or early November here. The port's just sitting there with the 3 current docks waiting to be expanded. So where this project is headed, as I mentioned, the Corps of Engineers study selected alternative 8B, which is what's shown up here on the screen. But 8B is a relatively large project, even broken into the 3 phases. It's a relatively large project. This presentation is mainly going to focus on phase 1 of the design, since that's the design work that was done, but I'll give you a brief overview of the entire project. Phase 1, as I mentioned, is going to bid in 2023, here shortly. Phase 2 is mostly dredge work, and is expected to be designed in the next year here and be awarded in 2025, with phase 3 designed in the next 2-ish years and awarded for construction in approximately 2027. Phase 1 has been designed to provide an additional 3,500 feet. The existing facility stops about here where the cursor is at. It will extend the Armorstone Causeway approximately 3,500 feet, provide an additional about 3,500 feet of roadway access along the entire causeway, another 2,000 feet of dock facility and mooring facility, and approximately 10 acres of storage facility between the roadway and the face of the dock. When phase 1 is complete, the far south end, this is the south end where the cruise ship is here, far south end will be in about 42 feet of water. And then it tapers back up as you get to, as you move closer to shore. However, when phase 2 is completed, phase 2 is entirely dredge work. And phase 2 will extend the basin, the minus 40-foot basin, all the way along the new 2,000 feet of dock. And additionally, it will dredge the existing facilities in here where the 3 existing docks are to minus 28. That'll allow Nome to be able to berth a much larger class of vessel than they currently berth, in addition to having just a tremendously expanded amount of dock space and it will expand the capabilities of the existing facility somewhat by giving them additional 6 feet of draft to utilize those facilities as well.
What's their current draft?
The current draft at the existing facilities here is -22. So they'll get an additional 6 feet of draft. So phase 3, as I mentioned, is not currently in design, but it was the recommended plan to be implemented by the Corps of Engineers report in 2020. And as part of the recommended plan, this phase would take I'm going to move back one slide here. There's an existing east breakwater here. Phase 3 would remove that breakwater that was approximately here and extend it out slightly and turn the north-south section, this section here, into a causeway with roadway access that would allow for the construction of 2 additional dock facilities for Nome. In addition, there would have to be a new breach bridge that allows for fish passage and water passage along the shore that is in conjunction with the existing breach bridge that's on the existing causeway. So the last part of that would be this area in here. The last part of phase 3 would be that this area from here would also be dredged to -28 to match the dredging from phase 2 that extended the dredge depth of the existing facilities. So with that general overview of the project, I'll kind of go into some of the design details for the specifics for the causeway and dock structures. So the Army Corps of Engineers, as I said, took the lead on the design of all of the armor stone for the project. The new causeway armor stone will be very similar in design to the existing causeway. However, the rock design has been optimized to use slightly smaller stones than what they used in the original design. The outer layer A1 rock on both sides will be approximately 18-ton average rock size with a 25.5 or 22.5 ton stone for the maximum rock size. The under layer that goes underneath that, the E-rock, would be an average of about 1.85 tons. And the whole causeway will provide a 30-foot wide roadway access to the dock facilities with a relatively wide shoulder to place utilities and lighting, things like that, and provide drainage as well. So it's kind of hard to visualize the size of an 18-ton average stone. So these are the existing rocks at the causeway. The guy there is approximately 6'1", and he's standing next to kind of an average stone that's out at the end of the causeway. The new causeway stone will be slightly smaller than that, but not much. So it's pretty substantial and large rock to withstand the ice environment and the storm environments that get out there. Gives you a little visual cue as to what this looks like.
What's the closest source for getting that stone?
Cape Nome Jetty is about 12 miles east, and that is where all of the current stone for the existing causeway came from. And the Corps can't specify that the new rock will come from there, but that's the likely source that everyone is going to go after for it. It's too close and it's too high quality to be competitive anywhere else.
What's the durability on the rock itself?
It's very high quality rock. I don't have any specifics off the top of my head, but it's really high quality. The stuff that is in place has not suffered any degradation, and it meets all of the Corps' specifications for their rock durability. So on to the design of the dock structures themselves. This is a typical day in Nome during port operations. You can see it's a relatively busy port. They have 3 existing facilities, the West Gold Dock, Mid Dock, and City Dock. They're all constructed as open cell sheet pile structures. And I'll get into that here in just a moment. Of flat web steel sheets. They see heavy use throughout the season on cargo, gravel, fuel vessels, and the occasional passenger vessel. This is a high-end cruise ship that called to Nome just before COVID. So Nome really likes the high load capacity and the added upwards that they have 6 of the open cell sheet pile structures. And they wanted the new facilities to provide the same or greater functionality in the deep draft portion of their new port. So the open cell sheet pile design is constructed of flat web PS31 or PS27.5 sheets. You can see those down here. It's just a knuckled flat web sheet. The face sheets are laid out in an arc, a circular arc. In the case of Nome, it's a 34.5 foot radius. And they're anchored into the structural fill in the back with PS27.5 sheets, which are just slightly thinner sheets, same knuckles, just a little less steel. And connected at each point by a Y pile. In the case of Nome, we have an XY pile that will be connecting these just for a little bit of extra redundancy. But they connect at each of these points and are anchored back into the ground. So P&D's design hundreds of these structures across the nation and internationally, including New Orleans and Umm with the Corps of Engineers and the U.S. Department of Defense. So the new facility will be a very similar design to this, and we'll be able to carry up to a 1,500 PSF uniform live load, 150 ton crane with a 70 ton pick, and basically any container handler or equipment that no one wants to throw at it. And just a quick note on the crane, actually, that's kind of a wimpy crane for normal industrial operations, but it was the largest crane that no one foreseeably thought that they would use. So that ended up being the design criteria for this. The 1,500 PSF is more than adequate to cover basically any crane that they would ever get out there. We did a similar design in South America, in Guyana, just recently, that's under operation for the oil fields. Slightly shorter wall than what's in Nome, not much, but a little, but in much worse soil conditions. And we designed it for a 750 ton crane with deck. So then that was running running as close as 5 feet up to the base of the wall. So this will certainly withstand a much larger crane than what's shown in the design criteria, if they ever wanted to utilize it. So just a cross-section of the planned new facilities, showing the dock, the uplands, the Cause River abutment, and the roadway placement. So on the north-south portion of the dock, it'll be slightly wider than the east-west portion of the dock. 195 feet on the north or the east-west portion, and 235 feet wide on the north-south portion. The roadway and surfacing shown here is gravel. This is a little bit of an older rendering. The city had wanted to use pavement for quite a while during the design, and after Typhoon Merbach, they had lost a lot of pavement along the roadway along Front Street, and decided against it, mainly because of the ease of repairability. And no, it's not easy to get pavement equipment up there, particularly the thickness of pavement that would be needed in a port facility that's going to be carrying around large cranes and container handlers and things like that. So we actually ended up with an interesting compromise on this, adding a stabilization admixture to the surfacing course. Typically used as a dust palliative, but it's also been used on several Arctic road runways. It helps prevent rutting. It promotes water drain off on the surface, and the runways love it because it minimizes the foreign object debris on the runways. The current facilities are just gravel, and in real wet conditions, they can get kind of muddy and messy. And this will hopefully alleviate a lot of that concern and give them a similar functionality to pavement, but something that can be easily reworked and easily reapplied, unlike the thick pavement that would have been needed at this facility. So while the design of the new structures is similar to the existing facilities, there will be a few differences. The face of the current structures are scalloped, as you can see here on, this is West Gold Dock. You can see they apex out and then come back at the XY or the Y pile in this case. So it's not a uniform face along the entire structure. The face of the new structure will have a steel face beam to provide a straight burning line across the entire face of the dock, as opposed to the scallop. And that will also allow for the installation of pipe full rail, safety ladders, mooring bollards, things like that, along the face of the structure. This is a similar design dock in Chignik that was recently installed just a few years ago, showing the face beam and the not the mooring bollards, but the pipe full rail, sorry, and the safety ladders. So it'll be a similar design to what's shown on the screen here. One other note is, because of the length of this dock, an additional 2,000 feet, we will also color code and letter the mooring bollards. So there'll be 4 distinct zones. So when the harbor master is telling people where to go along the dock, he can direct them to specific color or lettered bollard. So with the larger class of vessels that are expected to call to the port after this expansion project, they needed a higher capacity fendering system to allow for safe berthing and mooring at the new facilities. So fendering for large vessels in Nome is a super challenging prospect. This is West Gold Dock, or I'm sorry, City Dock, in the winter. So you can see ice pileup and EVU events are significant and common, and they impose large ice forces on structures. So the fendering either had to be compliant enough to absorb incoming vessel berthing and strong enough to resist huge ice forces in any direction, or it had to be removable. So we went with kind of a compromise between the two. The existing 3 structures that are in the inner harbor utilize a system. This is from, I think, City Dock, yes. Has a pipe pile back on that's driven into the ground and attached to the Y pile. And this, in the case of the new facility, it will be attached to the face beam with a rubber donut style fender on the front. So this will allow for like 90% of what is expected to come into Nome. So most of their day-to-day operations will be able to berth and utilize this. However, when they do get those larger vessels that need to come in, we added a floating pneumatic fender that attaches to the steel pile. This is a similar design on a different structure, but attaches to the steel pile. And allows the vessels to release their energy up against there and not damage the structure or the vessel. And it can also be easily removed in the winter time when the ice clogs the port and it's not they're not needed. Or if there's a big storm coming in, they can easily release these, pull back on shore so they don't get yank on the piles or destroy themselves. So it gives them a lot of versatility and something that's relatively easy to deploy and remove. And didn't have to be gargantuan to resist all the ice forces and also be compliant enough for incoming vessels. So, yeah, that's basically all I have. I do have one short little video if I can get it to play. But you can see it's a pretty exciting prospect for Nome. And Alaska in general. It's going to be a huge boost for the economy for a couple of years while they're constructing this. I do have a rendering of the dock that was done around the 65% design level. So it has a few items in there that aren't included on the new design, a few minor changes, but it gives you a pretty good idea, an overview of the existing facilities and the expansion. And if I can get it to play, bear with the music. It's I'd use something free or YouTube would copyright strike it. I'm not sure I know how to get it. Do you know how to get this to play, Andrew?
I think we get off the laser and go back to the cursor, and then probably it'll work.
There we go. So those are the three existing facilities. Mid-dock has a ramp for loading and unloading small barges. And the new facility, another 2,000 feet of dock, 40-foot draft. Just give you an idea of the scale compared to what they currently have. The original designs had a mooring dolphin out at the end, but we ended up encapsulating that in the cells and just putting an onshore bollard there. And with that, I will take any questions.
Awesome.
What is all that estimated to cost for construction?
So the last estimates that can be shared publicly were around 600 million for all three phases.
Couple of questions. You're talking quite a bit of material, you're talking quite a bit of dredge work and quite a bit of infrastructure that's going to be needed for this. What other port is it designed to be competing against? And where else has your design been used?
So as far as the ports that it's competing against, there's really not another port that it's competing against. It was justified on the case of supplying support to other communities, as well as a growing demand for an Arctic port. As the ice season lessens and lessens every year, there's just been greater and greater traffic across this area. So yeah, there's really not another port that is necessarily competing with. It's just that there's a need for it for the surrounding communities, and there's a projected need for it as the ice seasons lessen, get shorter and shorter. And as far as where is this designed and used before, are you specifically the dock or the breakwater or
Both.
both? Okay. And breakwater has been used all over the place, rock breakwaters, many places. It's fairly common. As far as the open cell designs, we have used them up on the North Slope for oil field companies. There's the seawater treatment plants up there have various open cell sheet pile designs. We used it at North Star Island for shore protection around North Star Island in about 40 or 45 feet of water, and even more stringent ice conditions than what is in Nome. We've also used them all over in many other places that are not Arctic environments as well. They're used. There's a few of them in Kodiak, all over the West Coast near Seattle. As I mentioned, in South America, in Guyana, there was just one put in about 2 years ago that's working down there on the Demerara River. We did one for the Department of Defense in Unkasar. And we did one as I'm just trying to think of some of the bigger ones. There was a PCCP, the dikes for works for the Army Corps of Engineers about 6 or 8 years ago.
Thank you.
How far are those sheet piles typically sounded?
So they don't require any embedment to be stable. We typically will put them 5 to 10 feet below the expected scour, in order just to make sure that there's no material that gets sucked out from underneath of it. They will actually remain stable. One of the design criteria is that they will remain stable up to and including, the fill being right at the face of it. So they're held up by the tail wall that are anchored into the supporting structure is actually this. The supporting structure is actually just this tail wall that is anchored into the ground. So the face of it that's actually embedded provides a little no support. It's really just a containing mechanism.
Could you mind going back to your roadway cost section? You had some material call outs that I was kind of curious about. I believe it was a black and white one, a little farther back. Oh, there we go. LSF fill. What are your fill materials in there on the interior?
Yeah, so LSF is actually the local service facilities. It's an acronym that the Corps of Engineers uses to describe the elements that are LSF is local service facilities describes the elements that are the city's responsibility to pay for and maintain. And GNF is the general navigation features, which are the Corps' responsibility to design, maintain, and construct. So this came directly off of the design drawing. So we had to signify that on here. Probably could have cleared it up a little bit for the presentation.
What's the primary source of funds?
It's all federally funded.
All federal.
Well, it's the entire project is federally funded for the causeway. I guess I'll get into that a little bit. The city will ultimately end up paying. The city of Nome will ultimately end up paying 10% of the general navigation features, which is the Armorstone Causeway, amortized over 30 years. The city of Nome is on the hook to pay for 100% of all of the local service facilities. So all of the dock structures that we went over on that will be paid for by the city of Nome.
And they already have a set aside funds or a reasonable structure for
That I
doing
won't go into.
Okay, sorry.
Yeah, no, that's fine. It's a legitimate question. It's just, yeah, they're they play it kind of close to the vest.
Can you tell me what their estimated liability is expected to be then?
I can't because it hasn't gone out to bid yet.
What were the other alternatives? You didn't show us, you said there was
Oh.
8F, what were some of the other ones that they
So
dismissed?
all of the other alternatives that they considered were just rearrangements of similar.
Same.
Yeah, so instead of having the L come all the way out to 40, they had another one where the L came out to like minus 28 or something, and then dredging. And this was the one that ended up coming out on top based on based on all the criteria that they were using. There was no other real alternative as far as not building an armor stone causeway. You could have done the docks differently than what they did, but it was just different configurations of the armor stone. Essentially.
Is it fuel unloading features
There
that
are.
get extended,
Yes.
that are extended to,
Mhm.
going both ways, I assume, to deliver fuel and receive fuel?
Yeah,
and all that?
that's one of the current issues right now is that the fuel vessels aren't able to actually berth at the port because they are not, or they draft too much. So they end up, for some of those vessels, they end up having lighter fuel in and out, which is problematic, as you can understand. Yeah, it's expensive. It's also problematic because you have to have all the environmental protocols if you have a spill or whatnot. And Nome relies a lot on fuel, so it's something that has to be done continuously. And they have to have enough to make it through the winter because you can't access this port in the winter. And that's what the community runs all of their electricity and all that stuff off. So
I should probably let somebody else guess, but is there any rehabilitative work on the existing features that's gonna be done, or how has the port withstood its life?
So the West Gold Dock has been there since 1981 and it's still in operation. City Dock was built in, I want to say 85 or 86, don't quote me on that. And Mid Dock has been there since 2016. The other various docks that are in the inner harbor up here, the Corps of Engineers has a Z-sheet pile wall that's in there. And there's also 3 other open cells that are in there that have been in there anywhere from 2005 to 2014. So.
And they're all performing expected within there?
Yep. We just did inspections on them a few years ago. Come up for the entire port facility will come up for inspection here again in another 2 years, I think.
Yeah, that's federally mandated.
It's actually not, it's all private, so the port just does it to make sure that they're running and they don't have any upcoming problems that jump out at them right away.
Thank you.
Yeah.
What's the design life with the open cell and this corrosion being considered as far
So
as?
there's a 30-year design life for those. Corrosion, you would think would be a big issue on these. In Arctic ports, though, we found that with the really cold weather, that's a hypothesis that it's just the cold weather, but we haven't found huge corrosion rates on these. You move down to Seward and you start putting steel in the water, and if it's not protected, it goes away pretty quickly. But Nome and above, we don't see very large corrosion rates. When we did the inspections of these and some other steel structures in Nome a few years ago, like I mentioned, City Dock, it's lost a tenth or a little over a tenth, but still well within operating range.
Oh, I was gonna say, with the dredge on the existing, the -28, did you have to do any modifications to those existing docks to accommodate that?
We just went back and had to recalculate and make sure that they were adequate for that dredge depth.
So there was enough redundancy in the design that.
Yep, there was enough in there. I thought I saw you raise your hand a second ago.
I did. One question. Good layout, good setup. Expansion on a facility, it's always something that is questioned from the day it's finished. How about this one? Do you have any ideas or directions that you would suggest for Nome?
I mean, if this goes through, I think this would probably be just about every open dream that the port director had, an additional 2,000 feet of dock space. I'm not sure she would be able to go back and say, yeah, we needed more at this point. I'm sure there will be some things that come up during construction that we will look at and say, okay, we could have done this a little differently. But as far as layout or anything, nothing's coming to mind.
Well, that was mostly the core, right? The core kind of dictates a little bit of
Well,
what the features could be.
So the 2016 and the 2020 report, the city was heavily involved with the core on those. It's part of they call it the 333 study. It's three years, like $3 million and there's 3 different entities. And so the city was heavily involved in swaying what those alternatives would be and everything. So, they had a lot of input into what ultimately came out of the options and how they were considered and everything. So yeah, I think it wasn't just a unilateral core decision for what finally got selected as the final product.
You had mentioned that there would be no use during winter, but with the possible floater security guards coming up during winter time, would it still be able to accommodate their use?
Yeah, I mean, if you can get a vessel in there, you can certainly use it. It's just that currently, it's 5 or 6 feet of ice in there in the winter and difficult to get a ship in. But that is one of the use cases that they considered in the Corps of Engineers report was potential ice cutter use. All right.
All right, well, I would like to thank you, Brian Hudson and the Engineers Incorporated for this presentation. The password for today's survey on the website is Modification, as is up on the whiteboard there. And thank you again for your presentation. Hopefully you can all join us next session. I think it's in 2 weeks. Thank you.